So, text mining begins with pattern matching, okay? So what's pattern matching? Basically, you're looking for matching words. So if I'm looking for a pattern like THE, that's the word the, but that's a pattern. I'm looking for the pattern of a T, an H, and then an E. So I can count how many times the word the appears. I can do that for any word. So there's more powerful pattern matching than just putting letters together to form words. And this is a tool that has existed for a long time. I don't know since when, 60s or 70s. And it's called regular expressions. And this is a tool for matching all kinds of different patterns. So what am I talking about? You can match words, like I was talking about, or numbers. Have you guys ever said Control F use Control F in a Word document? You look for all the occurrences of a word. That's a similar idea behind regular expressions. And sometimes you have a nice tool that lets you use wildcards. Like you put a star and it might match anything after those letters or something like that. You can also create patterns to match email addresses. And you can create patterns that actually look behind and look ahead of the text. So you only find a pattern if there's something behind it or something ahead of it. And you can use regular expressions to parse documents. So in other words, so when I was looking at item 1A in the 10K, I had to write a piece of code that could extract out of the 10K only item 1A. So part of the data preparation. Okay, so let's learn more about regular expressions. So here's a regular expression, okay? This is the regular expression. What is this, Stephanie? What is that? Yes. It's an A in quotes. But let's just focus on the A, okay? And what does it match? Yes. See, you know regular expressions. You didn't know you knew. Okay, Stephanie, I'm going to keep picking on you. Yeah. And what's that one? Same thing, so they match, right? It's like the matching card game. It's like the two match. Okay, Stephanie, last one, then I'll move on to someone else. Yeah, we'll just call it a star. I have trouble saying asterisk. So what does it match? Nope. There's no space there. Nothing. Okay, so A is the pattern we're matching, but the star modifies it. It says the A has to be there 0 to many times. So it actually could match nothing. Or an A, or a bunch of A's, or a bunch more. But that's it. All right, Vianney, since you're late, you're next. What do you suppose the plus does? Adds another A? So the plus means that there has to be at least one A. It's like a star, but there has to be at least one A. So an A plus would match one A, two A's, a lot of A's, but not nothing. Okay. Now the parentheses, what they do is they group, put the regular expression in a group, okay, before it's modified. So now the A, B are both being modified by the star. So what does this match, Vianney? Nothing? Yeah? Yeah? But not ABA. Why? That's right. It has to match A and B together. And here we have an A with no B. Now, a dot is a special regular expression. It matches any one character besides a new line. Everything but a new line. So dot would match, it's like a wild card, right? It matches A, 4, pound sign, percentage sign, capital A, capital B. It's pretty cool, pretty powerful. Now a /W matches any letter or number. So A, capital A, B, Z, 1, 9, but not one of these odd characters. Now, what if you want to match a dot? Actually, you put a slash in front of it, and then it will match a dot. So a / dot matches a dot. It's kind of funny like that, right? So if you have a special character, like a star, and you want to match a star, you put / star. It's called escaping it. So a / star matches a star. A W matches a W, but a / W matches any number or letter. It's kind of weird. But you get used to it once you learn regular expressions. Just a W. Yeah. So sometimes the slash makes a special character. Sometimes you use it to make it not special. Okay, so here's our first big pattern, okay? So /W matches any number or letter, right? And then the plus means it matches any number or letter one or more times. Then the @ symbol matches an @ symbol. Then another /W plus. Then a / period, which matches a period. Then com. So let's work through this. /W plus matches K, yeah, M, O, F, F, but does it match this, the @ No, /W wouldn't match it, only numbers and letters. So go back here, it looks to see if there's an @ to match this. Yes. Okay. Now there's an email, so that matches the /W plus. Then the period right here, and then com matches com. So this will match an email address, but it won't match this one. Why not? Because why, Mark? Because when you get to this dot, it says /W plus, okay, matches a K, that's fine. It sees a dot, but then it's looking for an @ symbol, and it doesn't match. Well, that's awesome. So this is like a phone number, and I think there might be a mistake here somewhere. So this portion is the area code. So a / parenthesis would actually match a parenthesis, because usually they're used to group letters or numbers or characters together. But a / parenthesis will match a parenthesis. The question mark means is a special character. It means that this parenthesis can be there 0 or 1 time. Okay, so star means 0 to many, a plus means 1 to many, and a question mark means 0 or 1. So I'm saying it's okay if there's no parenthesis here. /D matches just numbers. And then a 3 in curly brackets means there has to be 3 numbers. There have to be 3 numbers. And then I don't know. Yeah, so these 2 parentheses, not necessary, I don't think, but they won't break it actually. Okay, then we have another parenthesis here that's optional. Then an optional dash, and then we have these 2 parentheses, which are not needed. So then we have 3 more numbers, a dash, and then 4 more numbers, okay? But actually, you can throw in these extra parentheses, and they're not always needed. It doesn't break it. So this is a funny one. It's a Visa credit card number. So this caret means it has to begin with a number 4. And then there are 12 numbers from 0 to, okay, now there are these square brackets here. This is something new. If you put a 0 to 9 or A to Z, this will match anything between the numbers 0 and 9, or it could be A to Z. And then you want 12 of them. Then, actually I have no idea what the colon does. But we have 3 more numbers after that. That's only 15 numbers. 4 plus 1, 13, that's 16 numbers, yeah. Okay, so I copied these off the internet. An American Express card number, okay. Starts with a 3, then there's a 4 or a 7. This is what that means. 4 or 7. This one means there's a 0, a 1, a 2, or up to 9. So there's a 4 or 7, then there's a number between 0 and 9 13 times. Okay. All right. So what else? What other ones do I need to show you before you can work on this worksheet? Double-sided, nice. Ow! Okay. So we have okay, this right here. This means or also. So AB or DE. Okay? Either one. Okay, so remember this means or like 0, 1, 2, 3, 4, or 5. Well, this means everything but the letter G, for example. This caret in the square brackets means this will match everything but what comes after it. So if it doesn't match this, it'll match a number sign, it would match a parenthesis, you know, it would match anything, but not the G. Yeah.
The caret outside the brackets mean
So if you, yeah, that's because it's not, yeah, this caret before the 4 means it has to start with a 4. So whatever matching starts with a 4. Yeah.
inside the bracket there, it's better.
Yep. Kind of crazy, huh? What else? So this would match any letter. This will match any lowercase and uppercase letter. It's kind of screwy. That's how it looks. And oh yes, /s matches any space, right? All right, so first thing you need to do is open Excel. Come on, there we go. Gotta insert the developer tab. Okay. Now, we are only using a subset of all the powerful tools available in VBA. But we can't even access all of everything available unless we enable the libraries. Libraries are like other objects, other methods that you can use in your VBA code if you enable the library. So we have to go to. Oh, we have to actually open the. Let's just always enter the module. And then we have to go to references. And here are all the different libraries. See, there's some Acrobat Access 3.0 library, Adobe Acrobat library. If you Apple QuickTime control, if you add these libraries, then you can write code to control Apple QuickTime or Adobe Acrobat, something. I went to Tools and then References. So one thing I've done is I've used VBA to. No, I used VBA in Access. So I was writing code in Access to create Excel spreadsheets. And to do that, I had to make sure I had the right libraries enabled. I think this one right here works now for all of them. It's the Microsoft Office library. So I can manipulate Word documents, maybe PowerPoint, using VBA. All right, so there's one for regular expressions. Microsoft VB script regular expressions 5.5. Let's see if it's there. Microsoft. Yeah, I've got the library. So now I want my Mac users to tell me. Which is why in the business school you really need a Windows computer. But that's why I tried to get us the lab, which they didn't have for us every day. Okay. Well, I have now enabled it. So now I can write regular expressions. Yay! So I came up with something to do. I found a Word document. I created a text document called Alice Text. So what this is an excerpt from Alice in Wonderland. And this is where she experiments with drugs and all that stuff. Goes down holes. And I inserted a bunch of email addresses. Huh? That's just one email address, but we have to find them all, like Pokemon. And we're going to use VBA. Let's say we want to eventually find all the email addresses and put them into sheet 1. Okay? That's a pretty useful exercise. So in order to do this, let me zoom in for you guys. This might take a little time since I've never used regular expressions, but I have an example here to follow. Okay. This will be nice for you guys to see how I code new stuff, so you guys can see it's a struggle for everybody. So let's have a new sub called sub find emails. Yeah, let me put it on Blackboard. Good idea. Look, here's Blackboard. Okay, so now It's in under course documents, called Alice text. So save it to your computer somewhere. So one of the first things we need to do is what? We need to open the file, the text file, right? And read it into a variable. Now, if I recall, I had a method for doing that in my XBRL. Remember that XBRL assignment we did where I opened the XBRL document? So I'll just find that here. And I'll write it down and you guys can copy. All right, so I wrote this, see, I like to reuse my code, right, as much as possible. Function, import text file, string file as string, Okay, open file, forum. It doesn't matter if we know how it works, if we know how to use it. All right, that's the whole thing right there. So we'll use this function to open up the Alice text file. Right? You guys copied it? Okay. So I'll say something like the text is equal to import text file, and then I need the location of my text file, so I gotta go find that. No, I mean, I don't know. I mean, plain text. Yeah, remember my steps? Usually I always convert to plain text when I do text mining. And if I have a Word document, one time I had 100 Word documents, and I wrote this little VBA script that converted them all to plain text. So I didn't have to do them one by one, you know. So where is this thing? Alice text. And we could try it out. We say debug.print the text, right? So to see if it works. All right, where's my immediate window? And it worked. Yay. Okay. Now we need to search the text. So we need to write, let's write a regular expression, okay? And I need your guys' help. Okay, so we'll say dim string pattern. This is our pattern as string, okay? And apparently, here's a neat trick. You can set the value right away. String pattern equals, all right, email address. What do we do? Actually, we had an example up there before. So how should we match? What's the pattern we should use? Any suggestions?
W plus
Slash W plus at
slash W
slash W
slash period
slash period com. Let's say you can do com or edu or gov or what else? US, inf, I don't know, whatever. Okay. Good enough. I think that'll find all our email addresses. Now I'm just learning here myself, how do we actually use it? Okay, so we need to have a regular expression object, dim regex as new regexp. All right, so this is what we do. We say regex dot test the text. And let's say, we'll just say match equals. I have no idea what is going to be put inside of match. The first match, a list, I don't know. I've never used this object and method before. So let's just run it, and then let's put a breakpoint right there so it doesn't end it. Let's call it the match. So if I run this, I have no idea what's going to happen. Ah, so it says true. So it found a match. I don't want that. I want the actual matches, right? So how do I do that? Regex dot execute. Okay, just wants a string. The text. And let's stop printing this every time. Okay. Wrong number of arguments. Okay guys, I need your help. So Google this. Say VBA Excel find regular expression matches. Okay, so the execute method, a match or matches of pattern from a string is extracted. So we want to use the execute method. So I'll Google that. Looking. Okay, so I think I can do it. So if you set something as an object, that's just like generic. Here's an object. Okay, we'll put whatever we'll do whatever we want with it later. So we're gonna say set some to give the object a value. Use the set word. All matches equal to okay. So I believe now the all matches will contain a list of our regular expression matches that it found. Let's see if it works. Okay, it didn't throw an error. That's good. So what's the value here? All right, I want to view my locals window. So there's the text. There's the pattern. Where's the all matches? Aha. All matches. Whoa. Crazy. Okay, print all matches dot item 0. Print all matches dot item 0 dot submatches dot item 0. Okay, well, I'm getting closer, guys. So let's go to lunch. Let's come back at 12:40 today, okay? And hopefully after that, maybe during lunch I'll have figured this out. And I'll show you how.
First, you create a variable called and set it equal to whatever it's put into the quotes.
Which is my regular expression. for matching email addresses. Yeah, okay.
And then you set the variable called regex. I don't know what S means.
Okay. So remember I enabled a new library?
Yep.
So this is the object for that new library. So this can, if I create a new regex object, then now I can access all the new functions in that regular expression library I enabled. So you have to, I'm creating a new object called, regex is a new variable holding a new object called of regex p type, you know what I mean? Okay. Keep going.
So then you can variable called all matches. That adds an object.
Yeah, just generic object.
And
That's the
then
type, yeah. Okay, so there's this regular expression object that I created up here, and it has certain properties. And one of the properties is the pattern that it searches for. And so I set that property equal to this right here, right? Okay.
And then you set the property, the global property of regex.
Yeah, the global property is true. So I figured out that must mean when it finds a pattern, when it finds a match, it keeps searching the rest of the string. It won't stop once it finds a match. It'll look for more matches. As far as I could tell, it didn't work until I set that equal to true. It used to just find one match, but when I set global to true, it would find multiple matches. Okay.
The text is a string that holds a key that is
Yeah. Okay, so I have this all matches object, which will hold something, and I set it equal to the results of my regular expression object that holds my pattern. So remember the pattern for this, and execute kind of runs the matching on the text. And so it's basically, this is what searches for the patterns. And the results will be put right here, okay? And what's this?
For I equals 0, so from I equals 0 until so it counts the number of all matches, usually I count -1, and then for every instance between 0 and that number it prints out that number.
Yeah, so there's this all matches collection, and it has a bunch of items, and each item is one of its matches, okay? So item 0 is the first match, item 1 is the second match. So I'm making this loop through my matches to print them all out to the immediate window. And I have this variable I. First time through the loop, its value is 0. So that'll be the first match. Second time through the loop, its value is 1. That'll be the second match. And it goes all the way up to the number of matches, which is 4 in this case. So it's like 0 to 3, because it's 4 minus 1. So 0 to 3 will do 4 matches. It'll do 0, 1, 2, 3. So it'll end up printing out all the matches to here, yeah. So here's all the matches. Okay. Now, what would I do if I want to? What else could I put in this for loop so I can put all of these into sheet 1 instead of here? Let's say we want range A1 to have this value, rabbit, range A2, Dinah, A3, Smith, A4, Alice. What would you do, Ahmed?
All matches that item.
So it gave us, okay. What'd you say? Oh, you want to use offset? Row offset. I, comma. Nice. I was thinking of something different. This is what I was thinking of. I mean, that's better than what I was thinking of. What I was thinking of wasn't, I was just thinking of range A and I plus 1 equals all matches dot item I. Let's see if that works. Yeah, works. Did you guys get that? I just, okay. So now we can get a ton of documents and find all the email addresses, phone numbers, social security numbers, credit card numbers, whatever, and put them in a spreadsheet with just a short little script. Okay. Yeah. I'll save one. You know, when I was preparing for this class a few weeks ago, I was looking up regular expression cartoons, and I bet you didn't know there were regular expression cartoons. Whenever I learn a new skill, I concoct elaborate fantasy scenarios where it lets me save the day. Oh no, the killer must have followed her on vacation. But to find them, we'd have to search through 200 megabytes of emails looking for something formatted like an address. It's hopeless. Everybody stand back. I know regular expressions. Then he uses Pearl. Tap, tap, tap. And saves the day. Haha. Anyway, you can look up more on your own time. Alright, guys. I have more slides, but I'm going to do those last. I want to go through I have more slides about text mining. But let's go through some code first, okay? In chapter... This is really important stuff. I hope you guys read this chapter. Chapter 10. Now, all the chapters are fair game for exams, especially the VBA exam or test on VBA quiz, I call it. So chapter 10 is really important. So what's chapter 10 about? Who read it? Come on. You read it, Amit? Oh, awesome. Awesome guy. So this is all about controlling program flow. So what are the different ways to control program flow? Okay, there aren't that many. But you'll have to use them all the time. I'm sure you're going to use them in your group projects. So, we have a go-to statement, all right? So, this one, sometimes I use it for error handling, like if there's an error, I'll skip through the code and go to a different part of code. So error handling is like, you know how you run your code and an error just stops the whole program and breaks it? Well, you can say things like, if there's an error, then don't break the program, just do something else. Either just continue, or go to another line of code, or something like that. So there's this technique where you use the go-to statement to skip through lines of code. And this one in the book is kind of silly. So the way that the go-to statement works is within a sub procedure, you might want to skip to a different line. So for example, in this case, I'm going to enter a username in an input box, and if it's not Kevin, then it's going to go to a different line called wrong name. Okay, so I create a line called wrong name, colon. Okay, now this is exactly where it will go if the name's not Kevin. It'll skip everything else. Let's see, message box. Welcome. All right. Now, if it has the wrong name, say message box. Sorry, only Kevin can use this computer. right. All right, so if the username is not Kevin, it'll go straight to here, to wrong name. All right, let's try it out. Let's do it line by line. F8, F8, enter your name, Billy. Okay, username is Billy. F8, go to wrong name. Sorry, only Kevin can use this computer. Let's do it again. Kevin. Okay. It doesn't go to wrong name because it evaluates the if statement. Welcome, Kevin. Ah, space. There we go. Any questions about that? Mark? Ask for help from your neighbor. Well, that's what it did. Yeah, that's what it did. It went to the wrong name anyway. Yeah, so that's what I did. That's what I didn't do. I didn't exit the sub. I think you're right. I think I messed up. Good job. So now if I type in my name, it should just exit the sub. Okay. All right. Next one. So we know go to. All right. So if statements, we have one right here. You can write if statements on a single line. I could do this. I could say, let me save this one. I'll send all of this to you guys. All right. If statement example. So I could do a really long if statement. I could say if username is not Kevin, then message box go away, else message box welcome Kevin. Okay, so let's see if that works. Welcome Kevin. Go away. All right. That's one line, right? Or you can split it up, right? You say if, then, wait. But then you have to have end if. Apparently it wants the then on the same line. Okay. So if you have the if and else over multiple lines, you have to use the end if. Else without an if. Why does it have that? Why does it say else without an if? Oh. Guys, what am I doing? Ah. See, let's see if that works. Okay. See, I like it when you guys see me screwing around up here, struggling, because you'll have the same problem. It's like, except it'll take you 10 times longer to solve it. Okay. So, what about nested ifs? Well, let's not do the nested if. Let's do this one. So you can test multiple conditions, right? So in this one we have dim message as string if time less than 0.5, then so time is like a keyword in Excel. It goes from 0 to 1, and less than 5 means before noon. Okay. If time is greater than or equal to 0.5 and time less than equal to 7.5, if time is greater to 1.5, then message to evening. Okay, so what's this going to do? Summer? I said, what will this code do? Well, what do you think? Remember I said time, if it's less than 5, means it's before noon. The day is less than halfway over. Aiden?
So basically,
Aiden. And it correctly says good afternoon. Smart thing. All right, here's another example, and then this will be the last if statement. Okay, good. Thanks. All right, who wants to try this one? Jose? You want to describe what this code will do?
So first you move up to a box saying like enter quantity, and pick another quantity that you put between you put it from the if statement, so you put it between 0 and 25, and this one will be equal to 0.1, and so on. Like if it's like 25 to 250, which will be 15. It's like equal 50 and 75.
Yep. And then at the end?
It will show the work discount and the number is either 0.5 or like 0.1, whatever.
All right, let's try it. What should the quantity be?
0.5.
0.5? You want 0.5 chickens? Two chickens. All right. You get a 10% discount. That's too high. I think you should have no discount. But it says you do get 10%. This is just me talking. You don't have to say agree with me. But all right.
Can I ask you a question? Is there any significance to nesting the discount part? As opposed to just writing it right after the then?
As opposed to what?
See how it says discount equals 0.1?
Uh-huh.
Is there any significance to nesting it on the next line as opposed to writing it right after then?
Oh, yeah, I think you could just go like this for all of them. Yeah.
Then how can we look at the underscore?
Well, because we have this end if here, we can write it on different lines. And in fact, there are going to be multiple lines anyway because of all these else ifs, so we'll have to have an end if anyway. But it, you know, that's the thing. There's a few ways to format it.
Because usually when they talk about, well,
I mean, I could do this and it'd be like it's on the same line. And that should still work, actually. Okay, it says it doesn't work, so. Okay, so I'm going to delete it. You should play with it for sure. All right, so I'm going to take this and make it, show you a different way of doing the same thing, okay? So I'm just going to copy and edit this. And instead of an if statement, we're going to use a select case. And here's something. If you already knew everything you saw before, this is something probably new. Select case. So we have the same, but instead of saying if quantity and so forth, we'll say select case quantity. So what this statement means is we're going to evaluate the value of quantity that was entered, and then we're going to do something based on that value. So this is something I really like about VBA. And some programming languages have select case. Some programming languages don't, and it's really useful. It's really easy to use. So you say case 0 to 24. Case 24 to 25 to 49. $50 to $74. Case is greater than or equal to. Okay, see how that works? So we're evaluating quantity, select the case quantity, and if that quantity falls it'll only fall in one of these cases, right? So let's try it. I don't need that end if anymore, do I? There's no if statement. All right, stop. I needed something else. And select. And select. There we go. Wrong spot. Goes right here. And select. There we go. Okay, Jim. How many chickens? 49 chickens. You get a 15% discount. You should have bought one more chicken. Okay. And then the author goes on to show that you could put these on one line. Which isn't that big a deal. But you could say something like this instead. $50 chickens, 20% discount. Oops. All right. Page 151 of the book goes through this nested select case example that you might want to try out. It's where you check if something's true, if it's not true, you use a case else. Then you check if something else is true. If it's not true, you use another case else, and it filters down to quite a few indentations there that represent how nested it is. So let's skip that. And now let's go to for loops. Page 154. So Alan, this one's for you. You have to explain to the class how this works. Okay, Alan. And you just go through the loop. So watch this. Let's watch the locals window, okay? And let's go through this line by line. So we have total and the value 0, and count. Right now the value is 0. So now the value of count is 1. The total's still 0, but what do you think it'll be when I go to the next line? 1. 0 plus 1 is 1. Yep. And next count says go back to the for loop. Which it did. I guess it doesn't go to the first line of the for loop. It just goes into the loop. Count is 2. What's the total going to be now? 3, someone said. Bingo. Now? 10, 15. I think you get how it works. All right. Now can I just run the rest of the... Okay. 500,500, but we all knew that anyway, right? Because of the trick. You know that trick, right? Adding 1 to 100. You know that trick, right? 101. 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. So it's just 101 times 50. Same thing here, except it's 1 to 1,000. So it'll be 1,001 times 500. Okay. So that's a for loop. And then they show this neat trick where you can do just even numbers or just odd numbers by using the step. Okay. So we'll go 1, 3, 5, 7, 9, because it'll go by 2. What happened to my... There we go. So if we do this one, see, it's just doing odd numbers. Tricky. Okay. So what would it be? 1 plus 999? This would be 1,000. So would it be 250,000? I don't know. Yeah, 250,000. There you go. Okay. All right, let's do this one. Ashley, this one's for you. Function, text part, str. This is function instead of sub. Text part equals space. For I equals 1 to str if is numeric. Oops. Str, comma, I, comma, 1. Then set else. Text part. Text part. I don't think they're supposed to be space. Man, I don't even know what this does. Okay. Well, I could know if I went line by line, so. Go, start with the first line.
Okay. So you're performing a function.
So str is a parameter. Actually, it's just called str. It could be, doesn't have to be a string. You can say str as string to force it to be a string. So we can add that in. It doesn't matter. So this is a parameter to run this function, right? Okay. It's called an empty string, so it's nothing. Yeah. So this will give you the length of the string. So if it's the word 5, it would be 4. So. Yeah. Okay, so let's not call this string then. Don't take the middle. Well, it doesn't take the middle, but we're taking a substring of it. So. Starts out as 1, yeah. So I don't have much of a back here. It looks like it's just if is numeric, then exit the 4. Okay, I think this is what it's doing. If you have some numbers and letters jumbled together in a cell, it's gonna only put the parts that are not numeric. It's gonna stick all those parts together and call it text part.
Only to the left of the first numeric. Yeah, this example is only good until the first numeric.
Oh, it only goes up until the first numeric. Oh, that's what it does. So it exits the 4. Yeah. But we could change it to do what I said. So let's try it out. So let's have ABC, 1, 2, 3. So I should get just ABC, right? Next. What did I do? The end if, right, the end if. Okay. See, it says it's a problem with my for loop, but so it's confusing. Thank you, Alan. There we go, ABC. You're right. So if I put ABC and then ABC, it would still just give me ABC. Let's change it. So it gives me ABC, ABC. All right. Aiden. What do I do? So I want this, instead of saying ABC, I want it to give me all the text parts, not just the part on the left. So, yeah, maybe so it doesn't stop. So we need a way, instead of exiting the for loop, to just start back to the beginning of the for loop instead of exiting the for loop. So guys, figure that out for me. How do you do that? Go to Google. VBA. Start the for loop over without exiting. Or I could do it, but I'm asking you guys. You have 10 computers. You'll find it before I do. Do you know what to do? What? Oh, another for loop? I don't know. Well, why don't you Google it and verify it? Yeah, that's what I wanted to do. How do I do that? I don't know if I can do a go to like within a for loop. Or like just skip this part, right? How about if I said if the text part, let's see, if is not numeric, then do this. Maybe I should do that. Okay, check this. How do you check this, see if something is not numeric? Can I say if not is numeric? There, I'm going to create a new one. Like if we test if it's not numeric first, then that would work. That would work. If not is numeric, then do this. Else. You don't need the else statement. Okay, so this is what I'm thinking. If not is numeric, which means it's not a number, then it will add it to text part. If it is a number, it just does nothing. So this is called text part 2. Text part 2, text part 2. There we go. I deleted my end if again. Alan, you got to stop me from doing that. There, it worked. So, did anyone figure out how to just make it go to the beginning of a for loop instead? Could I have just written next I right here? I mean, that's what I was thinking. Like, let's see if this works. Instead of exiting the for, just say next I. Will that take me to the beginning of the for loop? I'm going to stop it here so it jumps into the code. Compile error. Did I do it again? No, it didn't work. It saw this next I. Okay. You can say exit the if statement, right? So if it's, how do you, no, end if would exit this. I could write 2 if statements. I don't know, whatever. If you guys want to play around with it, then you can. Okay. All right, guys. So that's a for loop, and then we have more examples of for loops, nested for loops. Okay, let's do the do while loop they have on page 159. Okay, sub do while demo. All right, Ahmed, this one's for you, all right? Do while active cell dot value not equal to empty. Active cell dot value is equal to active cell dot value times 2 active cell dot offset 0. Select. All right, what's this going to do? Okay. It'll test whether it's empty or not. So it'll change the value of the cell. It's okay. So let's say we start here. 1, 2, 3, 4, 5. Do you guys want to know what my lucky number is? It's my birthday. 10/24. That's my lucky number. Watch this. Equals. Let's see. How do you do exponents? Anyway. 10/24, that's my lucky number. It's also 2 to the 10th, which I think is cool. Okay. So my sister, whenever she sees 10/24 on the clock, she thinks of me. Now all of you will. Haha. Okay. So, play. Yep, it doubled everything. Just like you said it would. Okay, any questions on that one? That was pretty simple. Now there's a do while and there's a do until. So what's the difference? So a do while will continue to loop while the condition is true. A do until will continue to loop until it's true. Once it's true, then you stop. So let's do this. Do until demo. Whoops. Sub. Okay, we got 2 more of these, guys. All right, who's gonna do this one? Jim. Do until is empty active cell dot value. Active cell dot value is equal to active cell dot value times 2. Active cell dot offset 1. I should just copy the other one. All right. What's the difference here, Jim, between this one and the one above it?
You want procedure perform it performs it on the condition that it's on the
Okay.
opposed to do until performs the procedure until.
Yeah. And they do the same thing, right? So let's go back to here and run this sub, and it should double everything again, right? So, ooh. All right. All right, last one. So for each next. Sometimes, you know, we were running these for loops. We said, well, do it 1 to 100 times, or 1 to 10, whatever. This one is saying, let's just do it for each one, whatever number that is. Okay, so let's look at the example. So sub, delete, empty sheets. Dim worksheet as worksheet. Application display alerts. False. All right, who's going to do this one? Omar? You'll explain this one, okay? Thanks. For each worksheet in active workbook dot worksheets, if worksheet function dot count a w cells 0 This kind of looks like a dangerous one. What does it do? What is this worksheet function dot count a? What is that? So it's going to count. This is a worksheet function, like a regular worksheet function that you're used to using, and we're using it in VBA. So count a. If there's a value, you count 1, right? You get 1. If there's nothing, if it's empty, it's 0. And it's going to count a for every cell in the worksheet. If the worksheet's empty, it's 0. If there's even one item in one of the cells, then it will be 1 or more, right? Then if it's 0, then delete the worksheet. And don't display alerts. Don't say, are you sure you want to delete it? Just delete it. So it's going to go through all the worksheets and see if we want to delete them or not. All right, so let's see which ones are empty anyway. Sheet 1, let's create some new sheets. Okay, so sheet 2 and sheet 4 are empty. So let's try it. Play. Well, I can already tell they're gone. We'll go here. So they're gone. Yay. All right. So, all those are fair game for the test. Select the case, for loops, for each, if. What else did we look? Go to, do while, do until. Okay. Any questions? The quiz is multiple choice. Yeah. It could be on the quiz. Like, there'll definitely be some questions about. In fact, in each chapter, I'll draw questions. Yeah, yeah. The exam's comprehensive. So what's great is if you study for the VBA quiz, and I probably already said this. You study for the VBA quiz, you're studying for the final at the same time. So it's 2 for 1. You know. This is heavy. All right, guys. If I didn't tell you one thing, if I missed this thing I'm about to tell you for text mining, then you'd miss what most people do when they do text mining. So I got to get to this one. Oh, I need to save this and send it to you, right? Oh, it's in the same workbook, so I'll just have to upload it. I'll upload a new workbook that has all this code. It'll have both these modules. Okay. All right. Let me get off of this. Find the slides I need. Oh, really quickly before I get to this one thing, I want to show you where regular expressions actually come in handy, okay? Has anyone seen the clicker? There it is. So, this is a real case. Okay, this is real, guys. And I don't know. Maybe it'll make me a lot of money. Probably not, though. Because I'm not much like, I don't know. I have these visions and dreams of starting a business someday, but I'm too like risk averse to stop what I'm doing or use my time for it when I could be watching movies. So, here's a problem. Are any of you going to present on COBOL? Did any of you select that topic? That's too bad. So COBOL is a programming language. It's called Common something business, Common something business oriented language. What's the first? Oh, Common object business. I don't know. So it's a code for automating business processes. And it was invented in like the 60s or 70s by a woman. She's the mother of COBOL. I learned this from the student who presented on COBOL. And I don't remember her name though. Grace. Her name's Grace. Grace Hopper? I'm just not sure. Recording this? Hey, can you correct that for me? Just enter your voice and put her name. Okay. So what happened is with COBOL code, you can automate like payroll, you can automate all business processes, right? Automate everything. And you can store all this information in a database, and you can do whatever you want with the data. Well, some programmers for this bank that has COBOL code, which like all banks do still, they were giving themselves like discounts, removing red flags. Like for payroll, they wouldn't deduct taxes. Okay, so they were giving themselves all kinds of benefits because they were in the code, causing problems. So here's an example, right? So for product number 11998, and for this contract number, this T is moved to a field called this, which inhibits the collection of money for that contract. So basically, it becomes, there's no collection. It's free. Whatever, that product is free. Okay, that's the net effect. And here, payroll is linked to agency 09, account 55122 after September 8th, moving 100% exemption from taxes. So there's no taxes. For employees who are part of the above agency, they don't have taxes withdrawn, okay, or withheld. All right, so funny stuff going on. So these programmers are basically committing fraud. So I was shown these examples, and I was told, can you help us find similar cases in the code, right? And I said, oh yeah, because I know regular expressions, just like that superhero in that cartoon we watched. And I said, I bet there's a pattern to this code. So if you guys notice any patterns between these two, I should put them on the same slide. But here's one. And here's the other one. Let me put them on the same slide. There we go. John. That's one of the patterns. They both have an if statement. They don't both have an and. I don't think. There's an and. There's no and. They both have an if statement. Excellent. That was one of the things I noticed too. Move. They do both have a move. Excellent. These are things we can put in our regular expression, right? Yeah, the actual text, like patterns in the text that are the same. No, it's just text. It's a keyword in COBOL that means equal. So you're telling me how to write a pattern to match that. But do you notice any similarities between the two? Besides the if, there's a move. And then once we find the similarities, then that'll inform us how to write a pattern that matches both of them. And then maybe others that are the same. Well, the other one, yes. Oh, yeah. Excuse me. You know, after every line in all the code, there's something. I think this might have to do with the file name. Actually, when I was reading about COBOL to figure out how to understand, I didn't see anything that told me what these meant. But this is on every line, and so is this. So there's 1,000 lines of code in one file. Every line would have this at the end. And it changes depending on the file name. But I don't know why it's there. Other than that. There's one more big one. It's not hard to see. It's pretty obvious, so you don't want to say it probably. Oh yeah, well, line numbers. Yeah, line numbers also are always there. Yeah, I don't really know what that means. Do you see one here? Or okay, well here's the other pattern is that there are numbers. Numbers here and numbers here. So that turns out to be a big deal. So normally when you're referencing, when you're writing code and you want to reference a number, it's not hard coded into the code itself, right? You would, if you want to do something, maybe you're doing something with from a certain column from a table you're working with, but you're taking whatever value that is at the time in this column with this customer. But you wouldn't hard code the number in. It would be like a variable that's set at the time you run the code, but not in the code. You wouldn't hard code it. So that's what they told me too. I mean, they told me to look for. They told me that usually you don't hard code the account number, the contract number into the lines of code. Can you do that for every product and every account? That's like manually doing the work yourself. Why would you code it every single time, right? So it's not generalized as it should be. It's hard coded. So this is what I did. I wrote a pattern that looked for if statements, and if there is a long number, I call it, I think five numbers or longer, then it matches the pattern. And that's all I did. To start with. So here's my pattern. So the dot star will match anything. Like a dot member matches anything. Then a star matches 0 to many of that. Then it looks for an if. Then it looks for dot star, which could match anything else. Then it looks for a /d, which is number. And then 5 of those, and then a comma with nothing after the comma, which means 5 or more. And then dot star. So dot star, if, dot star, number, dot star. And I found all these. And I did other things that were like fancy. So before I even searched the if statements, I found all the if statements and extracted them from if to end if. I found the nested ifs. And then I checked those individually to see if they have the numbers in them. And it was so easy just to write this stupid thing, but the people I was doing this for were so happy. So they're sending me a lot more code to see if I could do other things with it. And then what I'm gonna try and do is identify high probability frauds, right? And the problem is there's millions of lines of code. They can't search them all. And probably when I search for this statement, like when I search for this pattern, maybe I'll find thousands of examples. And then it goes back to the manual work. They have to go and check and see if this is fraud and what's going on and why it was put there. So I have to, ideally, I can search for this pattern, find all the results, and in some other way, like you guys were saying, if I see the word move, then maybe that's a red flag, which will prioritize it as more risky.